It's on. Hey guys, and welcome to a session of L3 Plus Repair with Raz from Decentral. So I got some hashboard. I think we got like 20 or 30 of them. Obviously, I'm not gonna do all of them today, but we're gonna revise some of them together to see what are the main, what are their problems, and sometimes what are the main cause of why these wonderful miners are not working in this sessions. So first thing, we're gonna do some test, of course, with the tester. I am using ARC tester. So what I could use is this here. Let me grab my tester. There you go. And let's take a look at what's going on. I'm using a regular computer power supply. It's supposed to detect, yes, in a few seconds. Let's start that one. There you go. I can maybe show you with the multimeter what I will test. There you go. Let's go. Hi, Jonathan. How's it going? Okay, you see, yes. Okay, let's start this one. So first thing I'm going to check is, of course, if I got a chip map. This one is working. Sometimes I'm bending them a little bit because I know that many L3 pluses as well as S9 models seems to have sometimes a chip that has a weakness. So if I'm bending it a little bit, it can show it. Not in this case. So detection is great. Let's see advanced mode. Oh, test pass. Why? Only 10? Let's modify that setting. I don't like to be stopped, so let's see infinite. There you go. Let's try again. Nice. Okay. Let's see advanced test. Everything is fine. Let's see temperature sensor. So there's only one temperature sensor. We have a little tutorial that we call the under the hood of hashboard, and we just release one for L3 Plus. So go take a look, and you might learn a thing or two. And then let's see, restart test, but most of the time those boards are pretty fine. Okay. That one doesn't need any, seems to not need repair for now. So I will put it back into the warehouse for our other technicians to test that hashboard into a L3 Plus machine and see if everything is fine, and if something goes wrong, they can come back to me and show me more details of what's going on. Okay. So that one's great. Let's see. Second one. A little visual inspection. Everything's great. A little dusty. Here. I see some rust. If I'm taking a look here, I'm seeing some rust. So let's maybe just clean it before doing any test, because I feel that this one will have a boost problem. There you go. Oh, I will do some adjustment of my setup. It's not going to be long. I'm just setting my machine. There you go. And last one, plain sync. There you go. Okay. Okay, that one is clean. Everything else seems fine. Let's take a look. I'm testing with only one of those two 6-pin connector because it's enough for testing. You don't need to plug both of them. Whoop. I felt some resistance into the connector. Let's try it again. Oh, the board is unknown or the EEPROM data is corrupted. Okay. Let's try maybe with another cable or at least reverse it because sometimes it can happen. Or maybe the connections are rusty or something. Okay. Let's see if the EEPROM is not physically damaged. The EEPROM, I mean the PIC. A little bit of dust, same thing. Let's clean it with isopropyl alcohol. Yeah, let's clear all the zone. There you go. Seems fine. No corrosion. So let's try it again. Okay. The data is corrupted. So what I can do, I can reprogram the EEPROM. But for that, I will need to have the EEPROM of one working hashboard. I think I got one, but not on this computer. So let's see. So I don't know if I will be able to show you. But I will use a software that is called MP Lab X. We actually released a video a while ago about L3 Plus EEPROM reconfiguration. So you can go take a look on our channel. We got many other videos too. But mainly, while opening the software, I'm using what we call, there you go, Picket Model 3 in that case. And we're going to reconfigure the EEPROM. Let's see, settings. I will go advanced mode. And then basically, I'm plugging USB the Picket 3. I'm taking that little L3 Plus, and I will do very analog reprogramming. So there's here. Hey Alex, how's it going? So here we got some little connection. So this is the analog EEPROM configuration. So I will take that, and I need to use my picket. There you go. Now it's connected. I need to know what is the model of the PIC. So that one is PIC 16F1704. So I'm going to select it into my device. PIC SF1704. And once it's done, I'm going to apply. And then here, again, for more clarification, we got a video about that. I'm just showing real quick. Here we got, oh, Picket does not support. Let's restart that one. Yeah, sometimes it's buggy, so we need to restart it. Yeah, we're just gonna restart everything. There you go. Again, let's take the advanced mode. Yeah. Default password is always microchip. Select tool. There you go, it's detecting. Get tool support by hovering mouse over tool selection. Yeah. Well, it's a $30 setup, so don't expect to have 100% working every time. If I'm taking 1705, because most of the L3 Plus got the two different type of PIC, ending by that one ending by 1704, but many times there's 1705 too. So you can select that one without any problems. There you go. That's what I wanted to see. Now if I'm going back to 1704 and I apply, let's see if I got the option. Yes, it was just a bug. Okay. This plugging the Picket tool. And I'm selecting 3.375 because the PIC is working with 3.3 volts, so you want to be as close as possible. But if you put less, like by example 3.25, there's less chance of it working. So we just want to put a little bit more. But around 3.3 volt will be perfectly fine. Just don't put more than that. Don't put 5 volt into a 3.3 volt component. And then if we connect, what's going on with that bastard? Start again. Sometimes the actual fix takes less time than the configuration. Yes. Yes. There you go. It's loading. Currently loaded firmware, yeah. Target device was not found. Could not detect target voltage. Disconnect. Has somebody touched my settings? Let's connect again. But I'm just going to put a little bit of pressure on the plug just to be sure that it's connecting. Not found. Disconnect. Let's try the other side. Maybe somebody reversed the plug. Could not detect target. You must first connect to a target device. Okay, so now what I will do, instead of using the exact PIC model, I will select the other one. It seems to have to be less buggy. Apply. Yes. Going to voltage. Connect. Yes. Invalid device. What's happening? Disconnect. Yeah. You see, those new models are a little bit easier to reconfigure. But this is the way. Okay. Target device is an invalid device. So what I could do, I could literally change physically the EEPROM of the machine, because maybe it's my picket. Follow the arrow and pick it and connect the square. Yes, but any signs it seems not to be working. It's the first time that it's doing it with me. So at that point, what I could do, could just use another pick. Maybe it's just completely messed up. So I will use one of my scavenging board that I could have right here. I will try to take the same one here, 1.5. Yeah, if reversed, it will damage the pick indeed. So this is why it was supposed to work the first time. Ooh, 5.8, no. But yes, indeed, if you plug it the wrong way, it could indeed damage the hashboard. Let's take that one. Nope, I don't have it. Let's take this one. And let's see under it if it is 1704 or 1705. Yeah, seems to be the same model. I don't know if we see it, but anyway, it's the same one. put a bit of flux. I'm using for my air gun, I'm using Aten ST 862D. Very good, very reliable machine. Let's take a little closer look. There you go. So you get a closer look, and I got one too with my little scope right here. There you go. Or maybe I could use a little bit of cleaning just before. There you go. There. Nice and clean. We add a little bit of flux. Should be good. Let's put this one on the side. And we will let it cool down a little bit. I got a small fan on the other side, like this. Simple USB fan. And let's take another one meanwhile. There you go. L3 plus. Okay. Zero ASIC. What's going on? Put this here. Let's use multimeter voltage mode, second one. First thing first, let's see if we have voltage. We have voltage, so we got the 10 volts. So 12 volt from the power supply going with the step down right here, 10 volt that we can measure right here. I'm about 9 50, it's fine. And then let's measure the boost circuit. Boost circuit doesn't seem to be working at all. So if I want to confirm, I could take a look at the LDO right here. So LDO are working up to the last two domain, because the last two domain are linked to the booster. So I'm only reading, instead of 1.8, I'm only reading 0.17. Same thing here, completely zero. Yeah, booster problem. It's happening many times. It's one of the most recurrent problem with them. So let's power that off. There we go. So I got my dashboard right here. I will show you what I'm doing at the same time. So mainly I will take out all those parts of the boost circuit. There you go. First a little bit of cleaning. And then I will remove everything. I will also remove that component, because I will plug that little boost circuit. So that boost circuit will replace this one right here. No need to configure anything. It's already preset for the good voltage of the L3 Plus. That is around 14 volt. So yeah, it's very hassle-free component. You just replace all of that instead of trying to search what's going on with that dashboard. So yeah, it's a very simple solution that is available on our shop, as well as many other components. There you go. So now I'm using 70% of air, 470 Celsius. I just want to strip everything off. Now we'll go down to 25% of air and around 200 Celsius, because there's a small layer of acrylic right here that I want to clean. So I will mainly use that tool to strip most of the acrylic. Let's clean everything. Meanwhile, I can open up my Weller soldering station. There you go. So I will, meanwhile, my soldering station is heating up. I will prepare my zone. So there's three main parts that I want to prepare. Those positive and negative connection linked to the step down, so they will take the power. And then, so you can see here, I got the positive, the negative, and then the out source that I will plug on the out source here. Personally, I'm using C1072 capacitor that was here. I'm just stripping everything, and then I will put that one. Seems ready. Don't be afraid to apply flux. It's a life-saving tool for any micro soldering. Yes, and then okay. That one will be ready to test right after it's cooled down. Meanwhile, we'll take a look at that one that had peak issue. So let's see. It seems that it's not my wire, it's not my cable. Hey, L3 plus. So if you got many spare parts, it's another way to reconfigure it when you have some problem with your tools. Okay, let's fire it up. Fired it up. Okay, ready. Maybe there's other problem, but maybe it's just it. Woo! Okay. Yeah. You see, I got between. And if I'm bending a little bit, sometimes it's between 66 and 67. Okay. Let's take a look here. Is there any component missing? Seems not. I will stop, clean a little bit all this dirt and dust. Close power supply. Let's try it again. Yeah. So we'll start with measuring the LDOs. That one is fine. So number 11 linked to the booster. 1.3. Second one, 0.5. What's happening? I got, do I have juice in the board? I get a bad reading because it's too rusty or dusty. Because otherwise I wouldn't have 1.8 volt down here. So I'm just trying. Yeah, 10 volt, so that's fine. Let's see, boost circuit, maybe it's another issue. I'll just scrape it a little bit so my connection will be better. There you go, 14.33 volt. Booster is working. So it's might be a question, might be a matter of LDOs. Maybe the LDOs are defect, but might be a chip too. Yeah, 1.3, 10, and then 0.5. So again, here, my measure is fine. Let's take a look at the return signal. I'm pretty sure I will not have a good return signal. Yeah, it's not going all the way through because I don't have all the necessary power on the two last domain. 0.6, 0.7, the more down I'm going. So might be a chip problem, might not be a chip problem. Yeah, return signal is weak. Because if the last domain got problem, all the hashboard will have problem too. Okay. So maybe both of the LDO are messed up because they're linked together with the booster. But it could also be a chip between those two domains that is eating some power. So first thing I will do is try to change those LDO. So thing is, the two last LDO are pretty often different than the 10 others on the hashboard. So we need to find if I got spare parts of the LDO of the two last domain, it's gonna be way easier. And it can also better diagnose what's the issue. Let's see if I got spare last domain LDOs on my scrap board. Nope, 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 nope. I pretty much took all of them, except this one. So this one, let's take them right here. There you go. So I'm heating at 470, 55% of air. I will keep those two LDO that I'm changing on the side because if it's not the issue, I might keep them and put them back. There you go. So today is, of course, a quick repair session. I'm not gonna go more than like 30 minutes on each hashboard. So I will try to like one, two, maybe three things, and then I will put them on the side if it might take longer than that. Sounds good. So those two, I will put them here. Meanwhile, it's cooling. Again, we will take the other dashboard. Doug Money didn't, Jonathan from YouTube is saying, Doge Money didn't pump enough for L3 Hashboard. Be worth more than 30 minutes. Yeah, absolutely. Those machines are really reliable actually. But yeah, if they're breaking up, the other one, if it's not the LDO, might be a chip, but those dashboards are not as clear as other models. By example, 17th generation is very clear on their testing points. L3 Plus, it's not really showing if it's a chip, if it's an exact chip that got an issue. Might be the tester too that isn't optimized to that model, but it's pretty old. Not the tester, I mean those dashboards are pretty old, so maybe the reverse engineering isn't perfect neither. So they didn't put that much time to make better diagnosis. Most of the time, it's pretty fine. So if it's too complicated, I will just put it on the side. But for now, let's see if booster is clear. Yeah, here. Yeah, detecting. Let's power on. And let's see. I got my small light, but still zero. What's happening? I will start by checking if I got power here. I got my 9 volt here, 14 volt. So that's great. Do I have... Oh, I'm lacking power into the LDOs. Or maybe I got one LDO that is weak. But if I'm taking a look at the boost circuit, same thing. What's happening here? Because my boost circuit is fine. 9, 14. So let's see. Start with the first one. Good. 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 As long that it's around 1.7, 1.8. Ooh, getting weaker. No, it was just a false connection. And here I got to, again, last LDO problem. That can happen too sometimes because those two are linked to the last so because the two last domain are linked to the booster, if the booster fail, maybe my two LDOs got problems. So I will test the other one, and if the issue is still the same, that means that the LDO of the other one are fine. So I could take them and use them on this one, and then make test to see if it's working well. Let's close that. And let's see. Same thing. So if I'm measuring again, 1.3 and probably around 0.5. Yeah. So my two other LDO are fine. That means it's a chip problem. So now, what's going on? What I could do, I will stop that test. Maybe it's chip number 68 because it's blocking right here. What I will do, I will apply some pressure on those chips. So you see, every time that I'm playing with it a little bit, it's going back to 67. Now I'm back. Yeah, I got pressure. Now I got no pressure. Yeah, so there's definitely a problem with the last domain. Could be the last one. So honestly, that problem is kind of painful because you need to determine which chip has a weak connection. What I could do, I could maybe do some diode test. So looking at the quality of the connection with the resistance. So diode mode. And let's go 0.4. Let's compare to maybe another one. So 0.6, 0.4, 0.4, 0.4, 0.4. Let's see the return signal. All around 0.4. Okay. Let's see this one. If you want to take a closer look at what I'm doing, for example, here, I'm just measuring with the ground here and then clock signal. Yeah, clock signal is good. 0.4. Return signal, fine. Okay. Let's the next one. Fine. As long as it's around 445, connection seems to be good. Then afterwards, I will try to take a look at the connection between the LDO and the actual chip. Last one. 472 is a little bit higher than the other one, but that one is high too. A little bit higher, but not that much actually. Not enough to be concerned. Okay. Now, how to measure the actual connection between the LDO and the chip. There's two here. There's two small capacitors. There you go. There's two small capacitors. One of them will give me, if I remember, around 20 or maybe. So that one is around 80. And that one is around 40. Let's take a look at another domain to see if the connection is the same. Oh, you see, I'm supposed to have 22 here. And then I'm supposed to have 40. If I'm going with another one, 20, and then 40. I'm taking a look to this one, 20, 40. If I'm going to last one here, 20, 40, so there's no reason why. Oh, you see, now it's 22 and 40. Okay. That one, no, that one is fine. 20, 40. Oh, oh, maybe this one, 40. Oh, weak spot. Yeah, it's pretty messed up. So if we take a closer look at this one, here, it's all rusty. So we'll try to clean that. Yeah, someday we will have a good microscope. That one is just like level 1 microscope, level 2 microscope. It's fine, but the autofocus and the adjustment, it will be really easier with a real microscope. But those ones are quite expensive. So if you like what we are doing, please like and subscribe. That's helping us a lot. Maybe even help us to get one of those mighty microscopes. I will start with that one because it's in the same zone, but I don't want to strip them too quick. I want to be sure that it's well melted. Otherwise, I have a higher chance to take the copper out of the actual hashboard, and you don't want that. Okay, so that one, there you go. Here's one. Let's put that to 480. There you go. Okay, so that one is nice and shiny and clean, but not this one. So I will try to save it. That one is fine. Let's see the second one. Oh, it's getting hot. Hmm. Let me get a closer look. And meanwhile, let's unplug all that. I'll try to give you a good angle, but I need to work way closer to this one. So I'm scratching the surface because all the copper seems to be completely oxidized. So I try to take out the first layer so it could be nice and shine. Yes. All the other pads are good. Yes, I'm seeing some light. Okay, let's try it. So if I want to remove a little bit more oxidation, I will use my soldering iron and I will try to apply some new tin on it. But here I'm seeing something. I just scrape it. Yes, I will clean and show it to you. Oh, I could use, there you go, some light. Here. Yes. This is the one that I worked. And I will reapply just a little bit of soldering. There you go. Don't need much more. There you go. Now if I clean, it's almost as shiny as the other one. Okay. Yes. Now let's take this scrap board. Hello there, General Kenobi. How's it going? You have 4 L3 Plus to repair, 4 Hashboard or 4 machines? I think you mean 4 machine, but I just want to make sure because each L3 Plus got actually 4 Hashboard. So, you know. Where are you based? France? No, I'm French, so maybe my accent in disguise, you uncover it. But we're from Montreal, Quebec, Canada. Where are you from, buddy? Machines, nice. Not nice because they need repair, but it's perfectly doable to repair them. Ireland, nice. I want to go to Ireland someday. I went to Iceland. I was about to go to Norway, but Iceland was so, it's not cheap going to Iceland. It took all my money, so I didn't have enough to go to Norway and then Ireland, sadly. Shipping wicked expensive these days, and they weigh a lot. And actually, these are very light. L3 Plus are very light machine compared to, I don't know, 17, by example, S17, the 17 generation, and even more weight into the 19th generation. So yeah, but I know that the shipping is a little bit costly, you know, gas expenses, and everybody want to travel too, so all the prices are going up. So just that repair, it might not even be the problem, and it's already took me like 15 minutes. So yeah. Another problem of those L3 Plus is that because they are a little bit older and sometimes not in really good conditions, they can get rusty easily, and all those small components are super important. And if they fall off like this, you need to take care of them. Otherwise, it's not going to work. So, whew. So I will let it cool down a little bit. How much cost for repair L3 Plus? I'm not a salesman, so I don't have the answer to that. I'm repairing them. But you can write to us on our website, on our email address, and I'm sure they will take care of that. Or I think we actually got the prices on the website straight away. I'm not sure. Okay, that one I had a L3 Plus problem. No, no. One of my LDO has gone to the ninth dimension. Shit. Okay, what am I gonna do? I'm gonna take a look at those last LDO to see what's their name and see if I got some upstairs in backup. C49HG, C49HG. And the other one, so these are the two last domain. The 10 others, or in that case, 4VK4, pretty popular ones. If I'm taking a look here, that one is DD7S. Yeah, DD7S. I think I got some upstairs. You know what? That one I will put it higher because maybe my hand stamped on it and just fell off. Yep. Well, it's gone. Okay. Oh, what website? Um, our website that is decentral right here. The I don't know if I can put the link. Let me try that one. There you go. Yeah, thank you, Jonathan. Price varies depending on the job. Not more than 200 for all for broken dashboard. There you go. Seems to work. Okay, let's go back. Uh, yeah, I need LDOs, so I will be back real quick. Going well. Bon weekend. No, just started. I need LDOs. No, no, it's, must be 30 minutes. Okay, I got some here. Nice. Hey. All right. Got some LDOs. Okay, so I got G49HG. I got here G49HK. It's gonna work. Those one will be. Will it work? We will test, but those are compatible. So I got many of them that I scavenged from other L3 Plus, G49HG, HK, HL, HH. My pleasure, man. So how is it going in Ireland? Is it cold? Here we just had our first snowfall, like 2 days ago. Let's put them a little bit further. And two. I'll literally put them away here. Away. There you go. While being here, let's clean a little bit. Is it working? I hear that my Bluetooth is my Bluetooth still here? Yes. Oh, did I lose sound? Hey man, thank you. Do you still hear me? I think I got some earbuds problems. I'm still hear the mic audio going on, but I don't know if you hear me. That didn't work. Make sure Bluetooth. Oh yeah. Thank you, buddy. All right. Let's go again. I got sound. Okay, that is cleaned up. Let's put back some flux. G49HK. G49HK. Yeah, but freezing temp, but here we have some freezing temp. I think now it's minus 2 or 3 degrees Celsius. And because most of the people on the road didn't have their winter tires, because the law for winter tires is December 1st. We had the first snowfall 2 days ago. Everybody got crazy. Okay, those two LD are fine. Now let's see. Elbow cuff? What do you mean? Elbow cuff. Okay, so I had those two that I wanted to measure the, where was I? Yeah. Diode. Okay. Whoop. Like this. Twenty-two, 40, 25, 40, and then 22, 40. Whoop. Let's clean that one. Elbow cuff. I wonder what kind of emoji it is. Okay. Again. 22. Ah, that's more like it. So you always need to make sure that your connection between your multimeter and your dashboard is fine. Woo! You see that one is showing me something way too high. Ah, 22 and 40. LDO connection is good. Diode values are good on all my chips. Let's plug it again. Because maybe repairing those two capacitor made the connection better. And if not, it will probably be a chip. But which one? Same thing. 5. Zero 0.5. Oop. So with that problem, there's not really a way to tell which chip is weak or got a defect. Could be anyone between 76 to 72. I don't think it's before that, otherwise it will be there will be other problem. But let's see in advanced mode. Advanced mode is putting a little bit more power into the dashboard. So if I'm doing that, advanced mode, okay, 75, 76, no, 65, 66. Let's try again. If I'm looking at 13 here, 0.5 here. Here I got same thing. I just want to have a clue. So how do I get it? It's fluctuating with 1.8. So yeah, there's definitely a problem. Here too. Okay. So what I will do, because I have no clear indication, jumping. I could try, but thing is, I don't have my full 1.8 power, so that might not be a clear indication. For those who don't know, we will show, but for the sake of the live, for those who don't know, I will show how to jump. 0.8 and 1.8. So the LDO of the right is the one with 1.8 volt. Okay, the board is still fine. I'm using one cable connected together, and I will jump between the connection of the LDO 1.8, so that one being whoop, here. So that one on the left is 0.8 volt, that one on the right is 1.8, and I will jump with the return signal testing point right up. Boost off? What do you mean? 10 volt? 10 volt is the voltage for the 10 first domains, but the last two, where is the problem, is 14 volt. And right now my 2LDO doesn't get all the power for them to work, but it's not a booster problem because my booster, I have the 14 volt. So if I'm trying something here, so you see now it's jumping. 61. If I'm going further away, same behavior. If I'm going to the first one, so if we take a closer look by example, again, this is the 1.8 volt capacitor linked to the booster. I will jump when I jump with the return signal. You see, 37. That is right here. So if I'm jumping with those ones here, 64, 65, 66, but yes, it's staying on 66. It's not doing anything. Neither. Nope. Yeah, it goes to 67, but it's because I'm applying pressure. You see? Yeah, so I will probably need to take out all the heat sinks of that one, of the last domain, to see what's going on under it. Anyway, it's not the longer. So what I mean by that, I can just take out the heat sinks and put them back again with thermal glue. Okay, I will try the first. So 67, 68, 69. Let me grab. going to be better with that. There you go. You can just apply a little bit of pressure under it when it's hot enough. You don't want to pry if it's not hot enough because you have a chance to take out the chips at the same time as well as the pin on the dashboard. So let's take a look with that one. Am I missing a piece here? Doesn't seem like it. So we'll put it on the side and try to apply pressure on the chip but without heat sinks. So let's see afterwards. Now we'll test the other one that I changed the two LDOs. Here. Yeah, 66 chip dead. It's not completely dead. There's something to do, but it might take longer than 30 minutes if I don't have any clue of the chip because mostly it's a chip. But how to find it? Because if I'm applying some pressure, the chip is working, but if not, it's not working. I don't think it's 67. I would think it's either 68 or maybe even 72 that is completely blocking. Let's see. Okay, booster is working. There you go. So you see that one, booster was the problem, and because the two LDOs were linked to it and it has problem, maybe power surge, I don't know, and the two last LDO weren't working correctly. So now if I'm bending a little bit, everything's fine. If I'm testing advanced mode to see the quality, whoop, whoop, just a little lag. Let's try again. Advanced mode is fine. Let's see temperature sensor. There you go. Yeah, successful repair. All right, let's put that one on the side. Or what I could do to actually finish it, because there's not much to do afterwards. I can just, clean a little bit what I did, clean the setup. Even if it's a no clean flux, sometimes it's good to just, clean a bit because flux can be sticky and some dust would stick to it and dust could create problem. Success. Yep. Here's one. So what I will do, I want to glue that little new booster right here to the dashboard, because obviously if I'm letting it like that into the machine, there's a high chance that it will go onto another dashboard, maybe heat sinks or something like this. You could apply two-phase tape, but I like this crazy glue. There you go. I like to put a little wave right here so the cable isn't going anywhere. And I like to put some on the cable as well. Those ones are fine. You know, you see, it's already glued. There we go. And that's it. Now, this one. Let's try again. Apply some pressure into a chip. So first attempt, I will do 3 attempts. Otherwise, it will take too much time. And even there, I will go further than only 30 minutes because it takes like almost 10 to 15 minutes to work on those two small capacitors. So this is my first, it's not really an attempt. My first attempt was the two last LDO, still not working. LDOs were fine. My second attempt will be, let me show you. My second attempt will probably be chip 68 because it's right after 67 and 67 seems to work pretty well. You see if I am applying some pressure. It's completely messed up. My third attempt would be chip 72 because it's the last of the domain. It might block the return signal. You see if I'm applying pressure, sometimes it's working, sometimes not. It's not 67. I don't feel like it's 67. I will try 68. If it's not working, I will try 72. If it's not working, I will put it on the side and work on some other dashboard because it could be anything between. Okay, let's go. So 67, 68 right here. Yeah. We'll apply some flux around it so it will be easier to take off because there's also some thermal glue. Oop. I got a pair of tweezers for almost every situation. I have those ones that got just a little curve, so it's easier for me to get those chips. So now I want to take off as much thermal glue as possible from the pins on the dashboard. So I'm just heating enough for the thermal glue to fall off, but I don't want to heat too much so the soldering is melting. Especially here. Yes, that's more like it. There you go. Let's cool it a bit, clean it. Yeah. Because I really want the chip to be nice and flat, I will rework that place here with that tool. There we go. I want it to be nice and shiny. Whoop, what's going on here? Oh, never mind. Whoop, some soldering ball. There you go. Aten? Yeah. Aten ST862D. Very good machine. It is also available on our shop. If you don't see it, we can you can communicate with us and make a special quote. Pretty much everything that we're using is, of course, available. Yeah, okay, seems fine. Now I need chips. I could take a chip from another hashboard. Yeah, let me do that first. Let's keep that one for later. If no, if I want a chip, I will take it here. There we go. So now what I want to do, I want to clean that one. I want to take out as much as possible um, thermal glue so I can put it on the other dashboard. Well, here. Yeah, well, yeah, there. Let me take off the other one. Oh yeah, I'm gonna take that one. It's way better. Here, I don't need. So again, I will heat, but not too much, because I don't want the chip to unsolder. But I want enough heat so I can take out all that thermal glue. So I'm heating at 25% of air and around 200, 212 Celsius. So this is just enough so I can take that layer off. And if I'm doing this on the other dashboard, I have a higher chance to damage it. So this is why I'm doing it right now. So once it's hot enough, you can just strip as much as you can. It needs to be nice and flat. Should be good. Just a bit here. There you go. You can almost see again the small Antminer logo. Now we'll heat, but from under. Because if I am applying too much heat uh, on the hashboard, there's a higher chance that I can damage the actual chip that I want to take off. Almost there. For what's remaining, I could heat it from above now. There you go. So this is the chip right now. And you see, because I heat from under, it's already nice and clean, ready to go in. So no need to reflow or anything. Yes, yes. Just want you to have, yeah, should be good. Okay. Just to be sure there's no plastic part under it, so it will be nice and flat. Yes. Now I'm heating at around, I'm using 33% of air and 480 because I want less air so the chip will not move too much, and I want a good amount of heat because they can take it. Believe me, they can take it. If you don't heat enough, it will not stick well. Oh, and I got another tool. Yes. That small fork right here. I will try to apply even pressure on the chip to be sure it's nice and flat. And now that my zone seems to be heated nice and slowly, I will power up. So 55% of air, but instead of 180, I will go, instead of 480, I will go 470. There you go. So I can move it. It's completely melting. Yes, yes, yes. It's nice and flat. It's not moving. Should be good. Whoop. Let's hit again. There's two small bumps. There we go. Now it should be fine. There we go. Now, obviously I will not test it right now. I will let it cool down a little bit. But meanwhile, I will take a new one. There we go. Okay, that one. A little visual inspection. Everything seems nice. Nobody seems to have work on this one. L3. Let's see what's going on. Zero ASIC. Why? First, let's measure if I got any power into the dashboard. And I do. 10 volt. Do I have my boost circuit? Nope. My boost circuit. So voltage is going in, but the boosting isn't working because I'm supposed to have 14 volts. So 10 volt isn't obviously enough for the two last domain to be powered up. So booster problem, probably again. You see, that type of problem is happening quite often. Because I want to strip everything, I'm going like 80% maximum capacity of air. That one is very clean though. Compared to the other one, you can see the quality of the connections. Zoom, zoom. Yes. Focus. Yes. There you go. Doesn't seem to have acrylics like the other one, or not as much, at least. So I'm just gonna clean the zone. There you go. Yes, like this. So again, preparing my zone. Nope, I need more. There you go. So again, I will wait for it to cool down. Meanwhile, I'll take a look to the other one. So, first, let's clean a little bit of flux that is under the chip that I just changed. Also, I want to measure diode values before plugging everything in to compare if my values are the same. So I'm supposed to have around 0.450. 450, 450, 450, 450, 450. Connection is great. Let's see. Yeah, it's the good one. Now we will plug it. And then let's power it up. Same thing. At least the connection is working well. Let's go for 72 because it's the last one of the domain. If that one is blocking, it's gonna block all the remaining of the hashboard. So let's try that one. Uh-huh. I think I lost the usage of my HD microscope. I will try to replug it. It's still a new setup, so some things might work, some things might give us technical issues. Let's power up again. Okay, this is working, this is working. That one. Let's see. Microscope. We've got some technical issues sometimes. Okay, unplug and try again. Woo! Just a small reset. Back on track. Okay. It seems to be working even better. Yes. There we go again. I just want to clean as much as I can. Yes. There you go. So again, I just want to apply just a little bit of heat. Just enough to clean the cracks between the pins. Take out all of that thermal paste. This side seems okay. Here maybe a little bit. Just want to make sure that no pins are messed up. Everything seems fine here. Okay, let's reapply some heat. So everything is nice and flat like before. There you go. Again, so here I got a chip. Seems to be new. Pretty much cleaned up. So let's try it. Yes. There you go. So I started at 33% of air and 480 of temperature. Again, because I want to be nice and slow with the heat. I don't want to put too much pressure onto the chip, so I can move it if I need to. So once it gets enough heat, I'm putting more pressure afterwards because it's already hot. So I'm putting 55% of air, but I'm lowering at 470 degrees. So result, it's sticking pretty well. And my small solder blob here took off, so everything seems to be good. Now, let's see if the other one will work. Meanwhile, this one is going on the fan. Okay, here, I just put the booster. Is it gonna repair it 100%? Let's see. Maybe there's some other issues. Maybe it will be like the other one, that the two last LDO will not work. Okay. Power supply up. It's lighting. Boom! Advanced mode. So you see, an easy repair on those dashboard if you don't have any powers to the booster, instead of trying to find which part is exactly lacking. Just strip everything off and take one of our booster. It's gonna be way easier. Working. There you go. It's already nice and clean. Maybe just clean a little bit. Woo. Let's glue it. Okay, so board is fine. Yep, that one will take more effort because you don't want to put the wire around here, because it's where in the dashboard it's where it will go. That's fine. Yeah, another one. Now, will it be a victory for this one? Whoop. Its dial values, good. 450, 450, yeah, 420, but 450, it's almost the same. Last one, yeah. Physical connection of the chip seems fine. Is the chip good? I couldn't know yet. Let's see now if the issue is gone. So, zero ASIC. It seems that the last chip that I put is not functioning properly. Let's just maybe take a look at the LDOs. .3 seems to be the exact same value, even worse on that part. Before it was 0.5, now it's 0.3. So there's high chance that the chip that I put wasn't working properly. So I will need to rework that chip again to put the dashboard back to the state that it was, and afterwards I could I could try to find the issue. But for now, that dashboard will go on the site. It's already been 3 attempts. I said no more than 30 minutes. It's about that for that one. Doesn't mean it's not repairable. It will just take more time. So instead of working on one dashboard for too long, you can maybe work on easier ones. This, let's see. Version 1.6.1, nothing seems to be missing. Nobody has worked on it from what I can see. Okay, let's try. Zero ASIC. Do I have power? Let's see a random LDO. LDO is working. So I should have my 10 volt. Let's see here. Again, you see? As easy as that. Thank you, Lucas Studios. How's it going? Again, booster problem. So you see, I'm just first thing trying to detect, is there power into the dashboard? Yeah. I got 10 volt right here. But I'm supposed to have 14 volt here. So the boost circuit isn't working properly. Booster problem. Again. Booster. I will put it on the side. And I will try to see if I got one that has other issues, so I can show you maybe something more. Oh, already. Here. 2 LDOs missing. What I could do, instead of trying to make it work, or maybe they're out because there's a booster problem. So I will plug it. I will test the boosting circuit. If it's not working, I will need to change it because that could damage the LDO. Maybe this is why they're out. So let's try. Yeah, obviously. So I got power into the dashboard. 9.5, and then I got 9.35. So boost problem and LDO missing. Probably somebody has worked on this one and was like, what? What's happening? And took out the 2 last LDO. Or maybe for scavenge part because he thought that it was unrepairable. Whoop. Another issue. Oh, low battery. What's happening? Close. Yes. Yes. Back online. Okay, so boost problem, LDO problem. Another one. Oh. There you go. Boost circuit power more than the last couple of row on L3 Plus. Yeah. So here's the thing. Let me show you straight on instead of quick visual. LDOs are here. All the parts are here. Nothing seems damaged. No missing heat sinks, no heat sinks sideways. That's the main thing that you want to take a look at. Powering. So I'm using, because you just came here. I'm here since like I think 2 hours. First thing, I'm powering up with just a regular computer power supply because it can send 12 volt, and this is what those little hashboard are using, 12 volt. Okay, let's power it up. So I'm having 12 volt. Oh, okay, that one is new. Or maybe the boost circuit isn't working properly and it's not showing me all the way. So here's the thing. I got 12 volt from the power. If I want to measure, maybe I could measure right here. Whoop. I got 12 volt. It's going through the step down right here, so it's stepping down to 10 volt right here, around 10 volt, so 9.5. And then from the step down, it's going all the way here through the boost circuit. And the boost circuit is supposed to give me 14 volt. And the boost circuit is working, so 14 volt. That is boosting the last two LDOs. So if I am measuring, so yeah, the boost circuit is actually boosting the signal for the last two domains. So now, if I'm taking a look at the LDOs, I'm supposed to have 1.8 to each of them. Oop. Oop. So all my domains are fine. Now, I want to measure the return signal. Return signal is great. We'll take another one. We'll take another one up to here. Return signal is great, but it's oscillating. Sometimes it's showing 1.6 or 1.7, so there's definitely something going on. Let's see number 33. So 1, 2, 3, 4, 5. Domain number 6. 1, 2, 3, 4, 5, 6. And then 1, 2, 3. 1, 2. This is the one that is stopping. And then number 3. We'll take a look. Return signal is great. Return signal is still great. Still great. Still great. Let's take a look at clock. 10 is high. That one was a little bit strange. Let's take a look at BO right here. Yeah, there's a high chance that number 33 is not working properly. But it will not show it as easy as the other type of hashboard. L3 Plus is a small creature of his own. Thank you and good work. Thank you, man. My pleasure. So from you too. I'm more familiar working with S17 and S19. Exactly. So and actually S17 and S19 are the testing signal is way more reliable with the ARC tester that we are using, because that one is most of the time is If by example, S17 Plus got a problem at chip number 32, it will show me something. Weak return signal, weak clock signal, or even BO or BI value. But those dashboards will just jump. So you see, because my clock signal is supposed to be around 0.8, 0.9, I will have it on the first domain. But it's, yeah, I will have it on the first domain. But the more that I'm getting further, the worse it's going to get. It will jump. So here I'm going 0.78, and here I got 9. But it's not the chip that is faulty. If I'm going here, you see now it's showing me 1.8. And I think you know this one, 0, 1.8, 0, 1.8 with the clock. So that one is similar. Oh, here I got a good signal. Here I'm good. Here I'm good. Oh, so maybe I'm on to something. And from here I got 1.8. Oh, let's take a look. Right from where I am, I had an issue, and then, boom, missing resistance. If I'm taking a look at the other right here, I got one. If it's not the problem, it's one problem. So I'm going to start with that. I use the same boost circuit replacement as you do for, but for S9. Yeah, S9, I think it's the same booster value, but we also have S9 booster only for them. We got L3 Plus booster only for L3 Plus. We also have universal booster that can go from a range from 2 voltage to 28 volt that we are using on 17 gen and almost, and sometimes on 19 gen. So if you want to, we put some video on our Discord channel. I mean YouTube channel. We also have a Discord channel. But if you want to take a look at the videos that we do, by example, L3 Plus, we do what we call under the hood. So a more clarification, I just explain it to you briefly. If you want more clarification or under the hood section, might be useful. And even if you're working with 17 and 19 gen, we are explaining some of them too. You might learn a thing or two. There you go. Okay, so that one I got a small resistance missing. Let me take one. Those ones are all burnt up. Let me get another one. Yes, here. Sorry, I want to give you a good angle. That's about it. Oh, I will need maybe to work it before. It seems to be some lost part on it. I want to be sure that the zone is nice and flat, otherwise I could damage the copper on the dashboard. Oh, you see, the resistance is right here, but I will still change it. Oh, the copper was almost gone, but it's still connected. Nice. I saved it. Yes. Yes. Just a bit of music. While it's getting colder, I will take another hashboard. Same thing. LD, we're still here. No damages. Zero. What's happening? Do I have voltage? Oh, oh, no voltage. What's happening? Huh. Power supply. Oh, what's happening? iPod Touch still disconnected. Connected again. No triples. Do I have voltage? I'm wondering if my power supply isn't the issue. So for that, we'll stop the test and try on another dashboard that I already tested. There you go. I got 12 volt. Okay. Let's try again. I got no voltage here. What's happening? So, No signal at all. Okay, so that one I don't have any voltage at all. What could it be? Sometimes it's the MOSFETs. Sometimes the MOSFET are just breaking up and there's then no power into the dashboard. Can it be the PIC? The PIC is working. Might also be here, the step down. That chip sometimes is breaking and yeah, can create some problems. Let's see if I have that part. You see it's happening quite sometimes, so I don't always have a spare part. Ooh, maybe I have. There we go. So that one is from a scavenge board. Is it working? I don't know. I guess we'll figure it out. 55% of air, 470. Okay, should be good. Meanwhile, this one is cooling up. Yes. cooling down. Let's take a look at the other one that I changed the resistance. You see that part isn't always the same. The other one was rectangular, that one is more square. But if it's not working, I might have an alternative. Um, yeah, resistance. So that small resistance seems nice. Let's measure it. If I remember, it's supposed to be around 5. Or maybe not. Oh, I think 5 is on a 17 gen. Okay, 34. 32, 34. Let's see the last that I just did. Yeah, same values. Okay, let's take a look. Same thing. But now, instead of jumping 1.80, 1.8, I got the value that I'm supposed to have. Okay, let's bend it a little bit to see if I got movement. 33. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2. Let's apply some pressure on number 32. Nothing. Number 33. Nope. You know what? I will mark it. 1, 2, 3, 4, 5, 6. 32. Let's take a look at advanced mode just to see. Not much. So you see, as I said, L3 Plus doesn't give me much values. Okay, let's close that. Interesting. I will take a look at diode values, resistance values of the chip to see if I got anything. First, are my LDO going well? It's supposed to be, yeah, 40 and 20, 20, 40, 40, 20. Okay. 472, 471, 450. Nope. All values are good. Let's take a look maybe at some others. Before that, I could try jumper too. Jumper method. Let's try again. Nope, nothing more. Let's take a look at return signal of almost all the chips. Yep. Nope. No more indication that it could be any chip. So yeah, I will try 33. For that, I will need to take off more than just that heatsink. 31, 32, 33. So why am I taking all of them? Because it will be way easier to work with because I don't have any angle right now. So how to take them off? I will just apply a light pressure, you know, just like this. There you go. If you work on a 17th generation, um, by example, S17 Plus, you know what I'm talking about. It's way harder to just take out one heatsink right in the middle of the dashboard and work with it. You have way more chances of damaging other components and as well as taking out heatsinks. You will take them out anyway, so you better control it. There you go, nice and clean. Look at that. I don't even need to clean it. Oh, maybe just a little bit here. There you go. Nice. Ah, new one. Now, do I have a chip? Maybe. You see, I got many of them, but they are not all worked up. I mean, they're not all ready to put on another hashboard. I need to clean them from their thermal glue. But you know, this one is great. This one is great. That's just clean enough. There you go. Seems good. There you go. Okay, same thing. Well, this one is cooling. Let's try to see if the chip was the issue on this one. That chip. There you go. Ready to power up. Do I have power? Just a little bit. Nothing at all. Might still be my chip that has problem because physically those those MOSFETs seems pretty clean. You know, if we take a look here, I could try to change them, but you know, they seems pretty clean. I got something else. So It's been a while since I've done this one. Let me let me remember. So here's the thing, because that part, step down. There's many other parts, but most of the time that one is failing. If I don't have another step down, I have, like the booster, I have independent step down that I can put. Oh, yeah, yeah. There you go. But let me, because I remember last time I did it, I took some pictures. Hmm. Okay, I remember now. Okay, so what I need to do, I need to transplant this one to bypass the signal, so the MOSFET will indicate directly to this particular step down to do the work. And to do that, I need to make some connections. So first thing, I will take out resistance number R24. That is right on the side of it. Yeah. Because that one is apart from the control of the step down boost. And then we'll do some work. I will maybe need another kind of tool. Let's see. Let's see. Well, so what I will do, I will prepare to work my zone. So I will apply just a little bit of soldering tin. This one. There you go. So I just apply a little bit right here. That guy. Yes, indeed. On est à Laval. And then I'm using those two. So down, right. Once those are ready to use, I'm preparing this one. Okay. This is done. Oh yeah, almost forgot. That part is a little bit harder because here there's so much soldering tin that it's gonna be harder to make it stick because I need those two connections to go here and then those two to go here. Yeah, like this. So what I can do, I will try to apply the same element. I will maybe need a bigger soldering gun. Oh, seems to have worked a bit. Yeah. If I have been trained on the job, well, actually, those L3 pluses was most out of my own curiosity because there's not many information about them online. So I've mastered it with mistakes, but yeah, most we actually do trainings here on most of the hashboard, you know, and yeah, with my colleagues we give each other some tricks, but for L3 plus there's not many of us working on them. You know, for myself, I've been working into the electronic industry for quite a while. I'm a hobbyist on this. I'm repairing many stuff, you know, tablets, phones, TVs, laptops, as well as video game consoles. So, you know, PC building, all that stuff. But those repair is quite fun too. There you go. That one is great. That one is great. Well, fusion. And now, if, we'll do the same thing on this one. Oh, let me show you what I'm doing here. I'm just putting some tin. I'm actually making a fusion because I want it to work well. And now, if I put this like that, there you go. Also, oh yeah, I got the other part too. I need jumper wire, very small cable that I will use on those MOSFETs. Okay, that one is connected. Now, second one. Okay, two of them. Nice. I also want the other one with the resistance that I took out earlier. Here. I got it. Oh, that one. Yeah, nice. Yeah, programming is not really my forte, as we can say. I'm more a visual guy, so I need to see. I'm also sometimes working. I like working on cars too, so I'm very like more of a visual repair person. I cannot stand to see one dashboard not working, so I can stay here for quite a while, trying to bring it back to life. It's like an operation. There you go. There you go. Okay, so I got 1, 2, 3, 4 of my connections. Let's solidify it here. Like that. I try to put it here. And then, oops, there you go. Okay, now the last part. I need to fusion those two pieces together. I know it's messy, but it does the job. Let's hope it was the problem, otherwise I will keep it on the side. Let's go. Yes, fusion. Last part here. Fusion. Nice. There you go. Now, the small parts. Hmm. Hmm. That one needs to go the highest possible. So here, here, like that. One, two, and the two others right in the middle. Three, last one. Oh, four. Okay, so this is what it looks like. It's messy. Okay, so let's cut some of those wires. 1, 2, 3, 4. Okay. So that one is linked to this one. Small resistance that I took off is connected down here, and the two MOSFETs are connected together. Yeah. Okay. Now, don't worry, those copper wire have a small layer, a small insulation layer on them. So even if they're touching together, there will be no short. At least not supposed to. Okay, now, ready to test if it's gonna work. Let's see. Look at this. Complete new step down. Okay. First, power supply off. That's great. This. Excellent. Power up. Let's hope nothing explodes. Still zero. Do I have voltage? Multimeter. After all that, still zero. Zero, zero, zero. Nope, nothing at all. And my power supply is supposed to be working. Yeah, you cannot always have great victory, but sometimes when you don't have power, this is very useful. But sadly, not in that case. Might surely be something else. Might even be the MOSFET. I should try the MOSFET, but not right now. Usually MOSFET, the default MOSFET is physically broken. Those ones seems pretty clean. You think? So you think I should just change the MOSFET? Yeah, I guess I could try that. But now, if I cannot really take them out. Yeah, exactly. But sometimes the step down isn't working properly, so I wanted to try that one. So now, if I want to take out MOSFET to try, I need to take everything off. What do you say? Should I try it right now, or go to another hashboard? You think? I've never done that one. So, what do you suggest? If I'm measuring resistance, for example, if I'm taking another one that is working, 13. The other one was 34. 15. 13. Or maybe if I'm testing this, okay, let's see the continuity. Huh, yep. I think it's short. If I'm comparing to the other one here, if I'm grounding, it's not supposed to touch. For example, here. Whoop! I think my webcam. I'm getting less and less batteries. So if I'm measuring continuity, indeed, here, it's not touching and it's not supposed to. But if I'm going here, it's shorting. So you see, I took into account that most of the time it's the chip of the step down, but it might only be the MOSFETs. What do you mean? I cannot really measure on this side because the chip are not connecting. Yeah, the ground is actually directly here. So there's ground. I got the ground on the other side, but here I cannot connect straight to the chips because the chips are glued. It's not a connection like S17, by example. So let's take all that back. But you know, I wanted to show you also how to install those step down module in case you got issues. So now you know. There you go. And then so you suggest to measure straight. You mean what, from here? Let's take a look. If I'm measuring here, okay, this one here. I don't know what you mean, man. Yeah, seems like it. Well, gonna try that next time. It's gonna be way faster than putting all this. Thanks for the heads up. Usually I will go for the MOSFET first, but as I said, I took into account that it's because physically they seems great that they weren't shorted. Yes. Yes. Where are you from, man? So that step down module is still good. Let's take those MOSFET out. No, it's good, man. It's great. It's nice to have some interaction, and also, you know, so some problem. We all have our own way to do it, and maybe I took the more complicated way. So it's good that you give some tricks. Eastern Europe, Kosovo, really? So you need to. So you're at work, but you can't focus. I'll try with that one first. Great pleasure. But honestly, MOSFET, I never measure them for short. I never think about that one. Most of the time, MOSFET are super fine on 17 generation. That is the one that I work the most. If L3 Plus got an issue, most of the time, physically, it's gonna be burned. So yeah, that one maybe needed a little heads up. Yeah, but mostly 17 series. You tell me about it. S17 Plus that I work with are real pain right now. We got many hard ones. There's a T17E that is very messed up too. Most of the time it is, because that capacitor is really sturdy most of the time. But you know, I could change it too. There you go. Should be good. Yeah, T17E is crap indeed. I got some here with me that got a boost module that got booster problem. So maybe we will take a look later. Okay, let's see if I got MOSFETs. I got some here. Maybe I should just change all three. Yeah, the other one it's less risk, but I know that those one are a little bit more together. But if the MOSFET are not sometimes if the MOSFET are too different, depending one model of the other, sometimes I don't know, I've seen incompatibilities. You work on L3 plus sometimes? There you go. One. To work on. I just couldn't work anymore. It's, it's 3 a.m. Really? Here it's 9 p.m. There you go. Okay. This is good. Yeah, in Canada, Quebec, Montreal. Okay, let's see that one. Meanwhile, this one is cooling. Let's take a look at here. Let's see resistance value. The diode is good. 450, 430, 430, 433, 430. Again? So here's the thing. It's an old iPod, and I think it doesn't have batteries anymore, even when plugged. I should try maybe to have more power with that little thing, that little thingy here. Let's try. Good. Okay, so diode values are fine on that one. Mm, tester. Oop. Again. Yeah, I think it's time to change it. Low battery, close. Why is it not charging? Oh, okay. Okay, now it's charging. Right, some technical difficulties with the main camera. There you go. Uh, depend. Right now times are a little bit harder, so we are a little bit less than before. But we used to be around, I think, almost 40. But with all what's happening, the BTC going down, so there's a little bit less customers, so we have a little bit less job. But yeah, around 40 people. So it's like small medium company. Okay, this L3 Plus. Let's see. Same thing. Let's see if my connection is still good here. Connection is exactly as before. Yeah. Well, so some farm are directly plugged to energy source. So many of them got free electricity, but not only that, it's still profitable depending on the machine. And also some people might be stacking too. So yeah, it's a market for everybody. Well, I'm whoop, it seems that I am stuck a bit because number 33 just been changed. I could try to change number 32. Sometimes it's happening that it's the exact one that is showing because I don't have really clear indication of an issue. Let's see return signal because sometimes it might happen that it's only one chip that is giving less signal than the others. Nothing at all. Yeah, you had this exact issue. Whoa, I had this exact issue that board earlier today in ASIC number 20 replaced the whole domain multiple times, still the same issue. Yeah, is your alt cap resistance, all it seems to be fine, but 20 ASIC, so I did not bother with it anymore. Let's see how your board goes. I will not, I've already changed one, number 33, because it was the next to it. Maybe it's number 32, but it might be another one into a complete different place. So this is one measuring them one by one to see if one was weaker. But yeah, those one are harder to diagnose on the chip level. Oh, no, it's fine. It's still fine. You see even here. Let's try. Let's try 32 for that one. And yeah, sometimes it's just you try. If it's working, good. If it's not, you try another one. So now let's go for number 32. Another one into the graveyard. Let's take one that I don't need to work too much on it. One seems great. Notice on all your video that you don't retain the ASICs when you reuse them. How come you get good result? I used to do that before, but I had issues very often. It depend of the chip. I am not reflowing them. I am not retaining them because those one are still good. There's not any pins missing, and it seems that there's still enough tin on them. But yeah, if there's not enough tin on those little pins, I will surely redo it. But yeah, not every time. You don't need to reuse them every time. Actually, most of the time, I will just take one chip from one that hashboard. I will try to take out the thermal glue, and I will just take it out and I will just reapply it straight into another hashboard because there's already tin on it. And yeah, most of the time I'm getting good results. So you see that one that I just put, same result that before. So it was a success on that one. If I got one that is seems bad and need rework, I will surely show you how I do it. Come with experience, because at first I had nothing, especially with L3 Plus. These are really heat magnet. They can take all the heat that you throw at them without any problems, and the chips are harder to work because of that. But once you get it, making sure that everything is nice and flat, and then it should be good. But maybe because now we are talking about it, that one is not going to work. So let's see. Then I started to use lower melt solder to retain the ASIC more. Now I like it more. Maybe the fact that I can put it in place in less time and less heat. Yeah, that's a, that's a good trick that you can do too. Personally, if I can keep um, the exact same type of metal, the exact same type of soldering tin from one hashboard to another, I will do it. But if I need to rework a chip, most of the time I will also rework the pins that are into the hashboard, so the fusion will be better. Okay, so that one needs to cool down. Let's take a look at the MOSFETs. Yeah, they take a lot of heat. And they don't even have heatsink in the back. Exactly. Yeah, those and honestly, those chip don't heat at all. I can most of the time, if I am using arc tester with power supply and I'm repairing 17 gen, I cannot go up to 20 cycles, otherwise it's getting too hot. That one, you see, I'm going up to 364 and then I could still talk without any issue. So that's one good thing about them. Yes, MOSFET. Let's see. Okay, power supply off. Hmm. Yeah, exactly. But I don't know about low soldering tin on hotter hashboard, by example, A17 Plus. I'm not sure because, or even a T17, because those one are getting hot pretty quick, and I don't know the result. I know that many people are using low soldering melt, but I don't think. Oh, camera is out again. There you go. Yeah. But I don't think that one is low soldering melt. It's just regular solder. Oh, that's really low. Let's see. So because I change MOSFET, sometimes it creates more problem. So I'm just putting glasses, you know. I can maybe check. I don't know about this one. Because if I'm picking another dashboard that is working, I'm doing the same thing. It's not connecting. That side is connecting, but not this side. That one is okay, but here it's not supposed to connect. That one seems great. What? What's happening? What? Okay, that one is normal. Bizarre. That's what it is for ASIC, and it worked just fine. Really? Um. Oh, so you've been doing this for quite a while now. No, I will not do it right now because I still don't have my step down here. So I will not do it right now. I will put back the original chip that I had. And see. Yeah, I prefer to have all my parts already connected before. So if it's working, it's going to work 100%. Really? You've been there way longer than me. I've been working in mining industry for like 1 year, 1 year and a half. Okay, now this one. Okay, so good. Oop. I will let it cool down because where I'm from, there's a lot of broken 17 series. Yeah, because they're harder to repair. Yep, and it's not going any better. Okay, chip number 32. Uh, let's see, diode values. Good, 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 good. Yep, we got a very good repair success with the S17 gen. Okay, this. As we talked earlier, so now we are talking about it. That one isn't working, but it's a random chip that I took. Maybe that one was a defect. Yeah. Yep. So you see, I will not take too much time on this one. I will put it on the side. Yeah, where do I put it? Here. Let's take a look at this one. This one has been worked on. So, one of my teammates, no temp sensor found. So physically it's here. Yes. Hmm. There you go. So let's see. Okay. Let's see advanced mode. Lots of heatsink to replace if chip are eliminated. Yeah. Yeah. But no temp sensor found. But everything is rolling. Okay. Well, let's change. Let's try to change the temperature sensor. It's actually very rare that the temperature sensor is failing on those hashboard. Or at least I almost never change. I almost never need to change them. But yeah, let's do that one. Yeah. Okay. One. Well, no camera again. There you go. Yeah. Seems great. Let's see. Let's put that one on the side. Okay. What was the issue with that one? Oh, yeah. MOSFET. Okay. Phew. There you go. All right, ready? Moment of truth. Yeah, power supply on. Let's see. Still 0. But do I have? Woo! Good news. I got 12 volt. But do my step down work? Nope. So my step down isn't working. Maybe. Yeah. Maybe it's the last MOSFET. Maybe I could change it. Sometimes it's happening. Maybe again it's my chip U73. But at least it didn't explode. Sometimes happens sometimes. Or maybe one of the two MOSFET that I changed, one of them was defect. Yeah, I will change it while being here. In this case, mm, the pick, maybe. Yeah, maybe in some case it's defect, so it's working like it's detecting the EEPROM, everything is fine, but maybe it's still a defect. Yeah, I remember it. Sometimes it has happened. It's been a while though. Most of the time it's U73 step down chip. Let it cool down. PWM, power. What are those three letters? Yeah, makes sense. Okay. Mm-hmm. Still zero. I might maybe change the resistances around. So what's going on here? I actually still have an issue. That dashboard actually have an issue. Otherwise, the written signal wouldn't jump like that. It would be constant. So that might be why I have a signal lost of the temperature sensor. Because if you're working on 17th generation of Hashboard, they will show you this. Yep. So if I'm taking a look, it's jumping. Okay. So now what I could try to do, there you go. I think I have a 6-pin variable connector that I could try. You know, that one. Okay. So one chip might have a weakness somewhere, but because the tester isn't always right, I will try to stress the chips a little bit. First time I will try this on those models, but mostly I got my 6-pin power here, but it's going to be linked for regular working station power supply. So if I'm taking here, let's see, I will put 12 volt. Nope, not this one. This one seems to be defect. Here. Okay. Twelve volt? No, that power supply don't seems quite healthy. I don't know why. You know, it's not my station. Some parts, some tools sometimes don't work very well. Let me grab maybe something else. Oh, that one is working. Okay, 12 volt. Let's try that. It's fine. Anyway, it's almost over, maybe 10 minutes. Okay, let's try that. 12 volt. Okay. Okay, I got power, but now let's see advanced mode with my multimeter. So here, I will lower the power until I'm seeing a different behavior. So I will still undervolt. There you go. Okay. That's great. So I want just enough power so the LDO are still working well, but I want to see different behavior. I am at 8 volt. Okay, now it's getting weaker. Let's take a look. Okay, so now My LDO are still working fine. All my LDO are still working, even if I have only 8 volt instead of 12, but it seems to be stopping at 40. And 1, 2, 3, 4, 5, 6 here. Nope. Let's continue. Yes. 7. There we go. So now I got all my signal are banned. But my LDO are losing power. Yep. But booster is still fine. So I will go just a little bit higher. 6. Oop. 7 is supposed to work well. So I'm still red, but my return signal is still fine. And start from here, I have return signal 0. "17. Here's 16. Okay. 17. From here, I am 0. So 16. 16 is not powered up enough. Might be a chip. Might be the LDO. 1659. Input 6. Yep. I don't think I'm gonna detect that one like this. Oh, 1.5. Oh, because I'm going down. Let's go back at 8. I try to see different behavior here, but you know, some are fine. This one is fine. This one is weak, 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 weak. This one is fine. What's happening? Nope. Nope. So I'm supposed to see a different behavior, but I don't see anything. Yep. So that one, I will try to change the part around the temperature sensor, and if I am not detecting anything, it's There's a high possibility that it's a chip, but so far I don't have any indication of which one. So yeah, last attempt, otherwise it will go on the side. I think that will be our last attempt for today. Yeah, those ones. Here. Here. If I bend the board, does the voltage still jump? Well, I can hardly measure it meanwhile bending it. Is circuit bending like jumping? I don't I don't think it's a I don't think it's a loose ASIC, because most of the time if it's a loose ASIC, if you're bending it, you will show different behavior. It might be a chip, but a chip that got a weakness somewhere. But Alex from YouTube is asking, is circuit bending like jumping? No. Jumping could detect if a chip got an issue, while bending is more for older model like S9 and L3 Plus. That when you bend the board, your detection, by example, earlier I had 66 ASIC chip detected on an L3 Plus, and when I was bending it, I was going up to 67. But sometimes it's more obvious than that. Sometimes you got chip number 34, and when you bend, you go up to 72, full hashboard, just by bending it, and then you need to find which one is the culprit. Okay. It forces contact on the separated pads. Yeah, something like this. What I found out. This is what he meant when you bend, you find chip because when it's a loose chip, it equal bad connection exactly. It's the most common issue for me, at least with T17E. Really, I never tried to bend those hashboard. Most of the time, uh, hashboard bending is really for L3 Plus and S9. That's the only times that I've seen those kind of board are reacting differently. Never on 17 Gen, but maybe I didn't work enough with a hard model of a T17. But I heard a lot that T17E is a real pain to repair. I thought that I would have time for working on T17E for tonight, but I think it's gonna go for next week maybe. Okay, so that one, let it cool down. Let's try. Yeah, you just wiggle a bit, like really. For example, left, right, left, right, just a little bit like this, and you get all ASIC. Yeah, and I thought as a joke, if we keep it bended and it work, maybe we could, maybe it will be still bended into the machine and work. But you know, okay. Here, last attempt. Let's see. Make custom bend frame and it worked like a charm. Yeah, put tuning pin on it like a guitar. Exactly. Yeah, funny people. But that would almost be easier. Okay, so are we gonna see some MOSFET burning today? Let's see. Ah. So even there, ah, my power supply is off. Now it's on. Oh, one sign of life, one chip. I got 12 volt here. I got 4 volt here. MOSFET are working. Must be a U73 problem. It's alive. It's not strong, but it's alive. So maybe step down, completely messed up, and then MOSFET shorted. Four volt touch pick with hand. Why? Because it will be hot. Never try that one. I will try. If it's still shorted, it will get hot. Yeah. Okay, let's try this one. Ooh, I'm all excited. Maybe we will find the issue. With our good friend Fitim Jashari. I hope I didn't scrap your name. Yeah, that makes sense. Okay. Here and here. Boom. Boom, bada boom. Ah ben, tabarnak. Well, we have some flux thing. If it's shorted, it will go hot. Actually, turns out it's working now. We have that smoke flux things too to detect short and super cold. Yeah. Well, now it's alive. I got 10 volt on the step down. I got obviously 14 volt on the boost. All my LDO are fine. It was a, if it was a car, we would call it a misfire. Advanced mode is working. Temp sensors. Well, the magic touch. Well, it's working. I will obviously test it again maybe next week. And afterwards, we will test it into a machine. But yeah. Surprisingly successful repair. Yeah, electronics. Sometimes you just need to put it, it's like plants. Sometimes you need to talk to them and put good karma, good energy, and they will work just fine. There you go. Okay. Or maybe it was bad contact with 273. I don't know yet. Let's clean that one a little bit. You need to touch it. Yeah. Magic touch. Magic touch technology. Yes, yes, we're repairing L3 Plus. You just need to bend it and touch it a little bit, put good energy, sweet talk to him, and it's gonna work out just well. Let's try again. Whoop, whoop, everything is unplugged. My bad. Yeah, man. I strongly I invite you to join our Discord channel. Most of the time we will say here if we are making other live video, and if you just want to chill out or maybe just exchange some knowledge that you have and that we have, the Discord channel is here for it. It's almost 24 hours. Nice, man. Honestly, it was a very good intervention. Maybe you put a good energy at a distance onto the dashboard. You can find the link into the video description, or if it's not updated because we just launched the live pretty quick, you can go to let me grab to another for example, if I'm going to YouTube and to any other video that we did, I will send you the link into the chat. Yeah, the computer is getting pretty slow. It's not meant to stream and making all that at the same time. D. Nice. Decentral right here. And if we're going, for example, to another live that we did, let's pause it, and then, oh, that one will not have anything. Or maybe, Joe, you have the link? If I'm going to this one. Hey, pause. Yeah. Join our Discord right here. Copy link. And there you have it, buddy. Oop. There you go. Well, so as I said, this one I will test it maybe next week. And I don't know if you were here before, but I had a total of 9 ASICs. So I got technically 4 of them 100% repaired. I got those 2 hashboard that have either booster problem or you see that one got 2 LDO missing, so those one will be pretty easy to repair too. So 2 more I'm pretty sure that I will get. Let's take a look at that one with the temperature sensor failing. Our pleasure, man. Thanks for being here. It's always good to have some company on a live stream. Yeah. Let's see temperature sensor. If it's not working, it's probably a chip, and that one will take too much time. Yeah, it will take too much time. Ouais, genre là. Well, I think that that conclude our adventure with L3 Plus for today. So many of them repair, and more to come. So thanks for being here, and see you next time.